A warm welcome. This is Electric Energy Generation Utilization and Conservation course with the lecture 3.6 focusing on welding transformer. We know transformer is a device which can step down or step up the input voltage and provide the required output voltage which is necessary for the particular application. Here we are using welding transformers. Nowadays we have many AC power supplies. When we need to use a motor generator set for welding, we need to run it continuously, which produces a lot of noise. With the help of welding transformer, if welding is done with the less noise, then that will be a greater advantage. So let us see about the construction of the welding transformer. 15 to 45 volts and has a high current value which is nearly 200 amperes to 600 amperes. For adjusting the voltage on the secondary side, there are tappings. Actually, it is not shown, but in the secondary side, we can have a adequate number of tappings in order to adjust the voltage. By this, the secondary current can be varied depending upon our requirements. These tappings are connected to several current switches. Now, one end of the secondary winding is connected to the welding electrode and the other one is the welding piece. Unnecessary current will be flowing due to the I square R loss. The amount of heat produced may increase as current increases and the proper welding between the welding pieces can be executed as it is. Because of this high heat, the tip of the electrode will be properly getting melted and it will properly weld the exact part which has been concentrated on, or the piece which is to be melted will be it will be welded very concentratingly, and while seeing that the voltage is nearly 15 to 45. So at 15 to 45 we can say the arc voltage appears, the arc is getting discharged at the time, and this is a point which will be the operating point for this welding transformer. Low voltage level or a greater voltage level. This is how the tapped reactor gets performed. And next, while you are considering the moving coil reactor, we can see that the distance between the primary and the secondary will decide the amount of current flow. If the distance between the primary and secondary is high, then the current will be less. So accordingly, we can move the coil with this movement arrangement. When we are moving this, the primary, the primary part of the transformer will be moving towards the secondary or away from the secondary. Depending upon that, the amount of current generated will be there. If it is closer to the secondary coil, then more amount of current will be generated. If it is far away from the secondary coil, the amount of current generated will be less. In such a case, we can produce the arc discharge in correlation with the amount of current which is generated. Similar to the magnetic shunt reactor, this is but in this case we can see we have a reactor coil here which is connected to the electrode, and this reactor coil is then connected to the second arm, and then it is connected to the work. We have the primary coil here. So however, how the reactor position, the height of the reactor is continuously varied in this method rather than in the magnetic shunt reactor method. The next one is the saturable reactor, and here we have the saturable welding transformer also. So we can see comparatively study both. So the reactance of the reactor here in this case is adjusted by changing the value of the DC excitation. So we can see the DC supply here. Based upon this DC excitation, the reactance value can be varied. And this excitation, DC excitation, is obtained across the it is applied across a DC transducer. So transducer is a device which can convert any signal into electrical signal that we know. And here, higher the DC currents, reactor approaches to saturation. This changes the reactance of the reactor. By changing the reactance current, by changing the reactance level, then the current can also be changed appropriately. By using the above reactors, current can be controlled with the help of, and this will be helping in the formation of the arc for the welding purpose. And this is the saturable welding transformer, the same as it is, except here we have a bridge rectifier. Based upon this action, the rectifier converts the AC supply, because here separate DC supply is given. Here in this case we are using the same AC mains as we are supplying to the transformer. These AC main, the supply is taken and is then rectified using a bridge rectifier and converted to DC, and that's DC supply. After passing through the rheostat, it is then supplied to the DC transducer. Here this will be of the same case. Then the operation is the same as that of the saturable reactor. Next, let us consider about the resistance for welding. Here, the impedance of the welding transformer may be very high than that. The impedance of the transformer is designed for some other purpose like that. The transformer impedance may play a role in the process of establishing an arc, and it can control the current to the maximum. Here simply we have a controller setup. This is a start switch. So when AC voltage is applied, here we have a clamp ammeter as well as the transformer. Here the transformer will be generating it may convert the adequate electricity necessary for the purpose of welding based upon this controller action.